Good morning. Welcome, people in the DC area. It's fantastic to be here. I hope that you had some good sessions yesterday, enjoy some good discussions in the booths or with our partners. And I hope as well that you take some good points from this presentation today. So my name is Fabio Rodriguez. I lead the Solutions Architects for Secure Hybrid and Edge, which covers a portfolio of the hybrid and edge solutions for AWS. And I'm based in Cork, in Ireland. And I'm delighted to have Seji Gawawo, which is a solutions architect in my team, covering the same technologies, and also partnering with Steve Algieri, which is the head of Envisioning Engineering, which he will have some very cool stuff to talk to you soon. So let's get started. Before we move forward, I would like to ask a question. How many of you are already using AWS services? Just show of hands. Fantastic. And from those, or everybody else, how many of you are currently working in a hybrid cloud kind of project, maybe in the next 6 to 12 months? Brilliant. Yeah. So I hope some of the points that we'll touch today will help you to make a decision, take the right decision as well, or at least give you some guidance of what you are trying to achieve. So enterprises are rapidly moving to the cloud. So there are a few reasons they are doing that. So one is to reduce costs, to be more agile. So you want to have an environment where you can deploy your applications quickly, have a fail-fast type of, let's say, mindset where you can deploy something, test, and say, OK, yeah, actually, we need to redeploy that. You just shut down. You're paying for what you consume, right? But also, this allows you to move fast in terms of digital innovation, because some of you might not be, your company is not core IT, right? So you have other business to take care of. So IT should be an enabler for you to move forward. So this can help you as well to be more agile from that perspective. But there are still, and for those applications, and the majority of them, using an AWS region is the fastest way and the easiest way for you to deploy your applications, right? So you have regions across US and across the world that you can utilize. You have a whole range of services, like 200 plus services, that you can take advantage of. But we still see, and that we heard feedback from our customers, we still see situations where customers need to have or an application close to where the users are, like the concept of the edge, and also applications where require low latency. And that's where we thought of a few solutions that we could help you. Move forward here, if you think of common use case for hybrid cloud, so as I was mentioning, support low latency. So if you think, for example, there are hospitals across the country and across the world, in some remote locations even, that you need doctors to have access to, I don't know, MRI scan or X-ray images. And that can be quite heavy, right? So if you go through maybe a small pipe that they have connected to the internet, that can be quite onerous for them. So if they have that data locally, close to where they're pulling that will help them a lot. So those would be certain situations, or applications that would be very latency sensitive. So you have video streaming, and you have a range of other use cases as well. But you also want to modernize your application and use some architectures where your developers can then think of new solutions for your users, right? So your users are, OK, so we are using a mobile application that, one example here, we have a mobile application for this summit, right? So your users are located here. They need the data fast. They need to load the maps for the location. So all this kind of data needs to be very close at the edge to the user, right? But then you have I can say that this is quite interesting in the region of the world I cover, which is EMEA, right? Data residency. When you're talking about, like, you have, for example, from an EMEA level, and then like European Union level, and then you have countries and so on. And all those countries will have data residency requirements. So they say, okay, I want my data to be within the boundaries of this specific country. And perhaps that country will be one of the places that we still don't have a region, like maybe it's planned for the future, but we don't have yet. So that is a perfect situation where you can leverage some of the services that we'll be talking about soon. You also think about cloud bursting and disaster recovery. So you have your applications running on-prem, right? And you need to expand that to the cloud. You need to have a DR scenario where you don't want to invest a lot of paying a data center that is at times just sitting there idle for you to be able to fail over, just for compliance requirements, right? So you need to think of situations like that as well. But also the fact that, you know, like some applications that are moving to the cloud, they also have that, you know, like maybe I have, I don't know, 15 types of workloads. From those 15, 10 of them, I have no specific access required in terms of latency and things like that. But 5 of them are very latency sensitive. And where do I put them? Like if an AWS region is not meeting that. So that's the point that we started to think and hear from our customers, right? So, and that's the key point where AWS started to reinvent the hybrid and edge computing, where we thought, okay, customers are constantly asking us, like, yes, we love the services, we love to start to use some of the components that you have within those services, but we have those requirements. What do we do? So AWS said, okay, so what we can do is to take those services close to the customers. So in different levels, and we'll touch to some of those levels in a few minutes, but you see that they are taking, for example, some of the specific services that we are running in a region and bringing them close to the customer in one level, close to the customer on another level, close to the customer inside their data center as well. So you still can have solutions that you have an AWS services running inside your data center, and we'll talk about that. So moving forward here. But running those applications at the edge can be challenging as well. So you have like, and I like these 3 points here, you have 3 laws that can sometimes stop you to make that decision, like the law of physics, law of economics, and the law of the land. Law of physics, we are talking about you cannot upload the data. Like you don't have a physical connection, right, to the cloud. You have a remote location, or you have perhaps a delivery van that's going and is collecting constant data there, but you don't have how to connect that to the cloud all the time. You cannot afford to upload the data. Perhaps the location where you are based, or the amount of data that you generate can be quite onerous, can be quite expensive. So, you know, like to constantly upload those data, imagine like sensors in a manufacturing or sensors in a smart city, for example, where you collect tons of data all the time. If you constantly upload that, you know, there's a cost associated to that. Or obviously the law of the land, where you're not allowed to upload the data. So as I was touching before, like you are supposed to keep the data to meet requirements in terms of regulation and things like that. You keep that in the country, you keep that within the state or within the municipality, or, you know, like depending of the location. So those are the challenges that we've seen so far with our customers. Based on that, what we thought is to, you know, like we start to develop a few solutions. So as I said, for most of the use cases, the AWS services within the region are perfect. So you can start to utilize that. But when I say about, you know, the different layers, I love the way this is showing a kind of a ripple effect, different rings, right? Where you take data and say, okay, some of the data needs to be located in metro centers, or you're talking about 5G networks, or you're talking about data to be located on premise, right? So I want to focus specifically on the part that we're talking about the on-premise data, right? Where an AWS Outpost can solve some of the challenges that we have. And for that, I will leave you with the very interesting talk that Serge Gao will do today. Please welcome him.
Thanks a lot, Fabio. Thanks.
Thank you.
And indeed, in this session, so we will be covering Outpost in the first part, but I would like to mention as well a session which was done by my two colleagues, Mario and Jared, yesterday, focusing on local zone, which will be available afterwards. So it's hybrid 202. And they are focusing mainly on the local zone, which is basically extending the cloud to a metro area. But today, and in the first part, I would like to focus mainly on on-prem environments and on AWS Outpost. So what's AWS Outpost? Well, first of all, it's a rack, 42U industry standard rack, right? But what is important to notice is that it contains exactly the same hardware, same instances, so for instance, G5, M5, R5, that we'll have in region, okay? So this is exactly the same hardware in region, meaning that what we are doing with this 42U rack, we are extending the Amazon infrastructure from the cloud, from the region, to on-prem, right? And because we are extending the infrastructure, we are able as well to extend the AWS services on-prem. When I'm talking about services, I'm talking about compute services, so the like of Amazon EC2 for our instances service, ECS and EKS, so our container and Kubernetes services, storage as well with EBS, so our block storage, S3 for object storage, and more than that, obviously, so with Cloud Endure, Amazon EMR. So what we have done so far is, first of all, extending the hardware, the infrastructure to on-prem environment. And on top of that, we are extending services on-prem, right? So in a nutshell, that's AWS Outpost. Now, I would like to go with you and go through a use case that we've done with one of our customers. So the customer is basically a stadium. So again, I'm from Switzerland, so I will try to stay neutral on that. But it's what you call here a soccer stadium. For some other people, it may be a football stadium, so I don't know where you stand. But it's basically a place where people and this great team of Marseille is playing. And what happened is that during the pandemic and after the pandemic, right, people were not really back to stadium. They enjoy watching game at home. They enjoy the experience. They enjoy being able to have friends, to have commodities all around the sofa and just enjoying at home. So it was quite a hard time for these people to get people back, fans back in the stadium, right? And they decided to work on that and to create a more immersive experience and to create additional situation for the fans to be more willing to get back in stadium. And it all started with, first of all over the stadium, they started to implement a private 5G, okay? So they were putting antennas all over the place so that both professional in stadium, so such as photographers or the crew within the stadium, but fans as well could be able to reach and to share this local network through private 5G. That was the first step. Second step, they bring AWS Outpost in the stadium. By doing that, they do have compute capacity, obviously storage capacity, and native services to be able to create additional experience. And they were partnering as well with local startups to be able to work on different kind of application and immersive application for fans. For instance, having like additional data for fans on players on the field, being able to see the number of pass, scores, obviously, and so on and so forth, so that people will be able to enjoy even more the game and the experience within the stadium. So first example that they did was, first of all, to work with professional photographers all around the stadium. They were taking pictures and sending these pictures of fans actually, and sending these pictures on giant screen all over the stadium. And they were able so that people will share their experience, we might share messages, and so on. And that was the first trial which was public and on which they communicated. So people were, yes, having like huge fans, scores, and so on, and being able to display that on the field. And actually, they were partnering as well, and they were having cameras with 5G phones on top of it, so that the picture will be sent directly to the giant screen. So, in a nutshell, how it worked on stadium. So, professional photographers were using cameras and 5G over the phone, publishing that into the Outpost. So Outpost was both a storage part and a compute part that I will explain in a few seconds. And they were able to share on screen as well as with journalists which were present on the stadium. But then a second use case was that they wanted to be able to publish these pictures for newsroom in region or in main places for the next day edition, right? So on-prem, within the Outpost, they created thumbnails, and they were sending these thumbnails in region so that the newsroom will be able to check which picture they want to select. And that is because these high-res images are quite big, and then in terms of bandwidth, were quite consuming to send back in region. Whereas generating thumbnails was much more easier, much more lighter, so that people will be able to consult faster images they want to publish. So that's one use case. But think about, again, they do have no on-prem compute and storage capacity, and they do have access to services. So next step for them is, for instance, to work on every month or so, they are organizing a scouting session. So all the young players from the area are coming to the stadium. I'm talking about hundreds of young players, and they are all playing within the stadium. And they have people all around the stadium trying to pick up the best players, right? Think about AI/ML in the stadium, analyzing the camera feeds, and being able to help them detect the next Megan Rapinoe or Alex Morgan or Kylian Mbappé if it's in France, right? So these kind of workloads will be implemented and will be running on-prem to help scouting people to pick up the best players. And then for the club to generate new revenues and obviously to find the best one, which will be the next big star, right? So this is one use case, but now they're working with startup and they will be able to deploy any kind of application because these startup companies are mainly working with AWS in region to develop their application. So to do that and to explain a little bit this Outpost on-prem and how to reach low latency, I would like to go through a quick demo with you. So it's a recorded demo just to be fully transparent. And within this demo, what I would like you to understand is the concept of the local gateway, okay? So basically, the local gateway will be the gateway between your AWS Outpost running on-prem and your on-prem world. And what I would like to show in this demo is how to leverage the local gateway, right? By updating your route table. In the first demo, what I will do is to try to update the regional route table. So I will go in region, and I will try to update the route table, trying to get routes, so 0.0.0.0/0 through the local gateway. And we will see that it's not possible. Again, we are trying to achieve low latency. Low latency meaning that the infra and the services are as close as possible to the data, so on-prem. In region is not low latency in this case, right? And in the second step, I will do exactly the same, but I will update the route table on the Outpost. So let's jump to the video, if you will. Okay, so in first place, I'm going into region. I'm selecting the subnet in region. And then, okay, so we can check that indeed it's not running on Outpost because here my Outpost ID is empty, right? So I'm just proving that it's really in region, and I'm going to the main route table. So I could have other route table, but I will use the main one for this demo. And I'm going to the route. I will edit the rule, obviously. And then I will try to add this route. So I could have checked any route, but I'm doing it for all routes. And I'm trying to use the local gateway. And here we go. That's not possible. Okay? So updating a route in region, trying to use the local gateway, which is this concept to get low latency, is not possible. No, let's do exactly the same as I was saying, but this time we are trying to update the route on Outpost. So same, selective the subnet, and this time the subnet is on Outpost. I can check indeed that it is on Outpost, right? And I will do exactly the same. So that's a route table I have created. That's not the main route table, okay? Going to routes, edit routes. Same-wise, I'm doing the 0.0.0/0. I could have chosen another one, but I was a little bit lazy on this one. Okay, save changes. And now the route table was updated. So again, what I want you to properly understand, and the really important point, is how to reach low latency and why we do manage to get low latency and to be able to answer these specific needs is through the local gateway. So we've been discussing about extending the cloud on-prem, so with AWS Outpost. Again, Hybrid 202, which is extending the cloud in metro centers, so local zone. What I would like to touch now is how to extend the cloud on edge environments. So first of all, let's clarify what we call edge, maybe. So edge will be a place where you have no connectivity or really low connectivity. Think about, I don't know, a battlefield where you don't have 5G, you don't have Wi-Fi, you don't have proper networking, right? Think about a boat which is sailing in the middle of the ocean, and the only connectivity it has, it's through satellite, which is limited. It's in the middle of a storm, which I hope it won't happen, and then they don't have any connectivity. So this kind of environment will be what we call edge environment. And so to help our customers in this kind of environment and to extend services in this edge environment, we will be able to leverage and to use AWS Snow Family. So Snow Family will be Snowball Edge with different options from compute optimized, storage optimized, or even with GPUs, to the Snow Cone, which is a smaller form factor with 8 to 14 terabytes of storage and some compute capabilities as well. And on these edge devices, right, you will be able to run native services, compute services, so EC2, container services with Amazon EKS distro. You will have access as well to S3 storage. So again, extending these computing and storage capabilities to edge environment, right? So in a nutshell, what we have seen so far is that AWS is reinventing the hybrid and edge experience by extending the cloud wherever our customer needs it, whether it's on-prem with AWS Outpost, metro with local zone, even 5G network with wavelengths that we didn't touch in this session, but as well as to the edge, right, with the Snow Family. And what I would like to do next is to welcome Steve on stage. We will go through a really, really nice use case using a snowball. Here you go.
Thanks, Veggie. Hey, good morning, everyone. Great to be here. So my name's Steve Algieri. I'm the head of Envision Engineering for Europe, Middle East, and Africa. And I'm here today to take you through one of our proof of concepts for a customer around the concept of situational awareness at the edge. So just a quick dive into Envision Engineering, or EE as we're commonly known. We are a rapid prototyping team within AWS. So we are there to focus on our customers' really hard problems or challenges that either they don't know how to solve or they've tried to solve and they've failed previously. We're really there to demonstrate to them, using AWS technology, what we call the art of the possible. So really delivering that AWS technology that moves their business forward. We also are there to create, although they are proof of concepts, what we call tangible and working solutions. So the aim of a EE POC is always to take it into production, either with the customer or with partners. And finally, we take the rapid bit really seriously, so we develop quickly. We always feel it's the best use of our customers' time to show them how we can do things with AWS and move their business forward. And we'll see what that means a bit later once we've gone through the use case. So this was the exam question or the challenge that our customer came to us with at the beginning of the year, which was, how can we detect signs of life in a chaotic, disrupted environment to ensure that we get the right help to the right place at the right time? It's a pretty big, ambiguous problem that we're familiar getting from our customers all the time. We had loads of questions around how do they define signs of life, what environment are we going to be dealing with, and how quickly do they need to get the data to make that decision. So we started with trying to understand those different parts. So we started with signs of life. So they wanted to know visual detection to start with. So within the environment that they were in, visual was a primary concern for them for detecting those signs of life. They also wanted to detect change in environment. So think maybe light change, microphones, sensors, and environmental changes as well. And we also wanted to focus on the detection of RF devices in the area. So that might be handheld radios or mobile phones. Maybe if the mobile phone network was down, we would still be able to detect phones that were hunting for a signal. From an environmental perspective, we had to assume that we potentially were going to be dealing with a reduced civil order within the area that we were operating in, which might also limit civilian movement. Additionally, we'd have to contend with limited or maybe no power and no communication, so a true edge environment from a compute perspective. And lastly, we would be dealing with potentially a large geographical area. So we knew straight away that we would be dealing potentially with multiple sensors within this environment. So given all of that, we also had to deal with environmental and human risks. So environmental risks might be earthquakes or tornadoes, and human risks might be mass migration of civilian population at very short notice, all of which makes it really hard to know where to put your resource to help best. So we knew very quickly on as a proposed solution that we were going to be dealing with both the edge and, where possible, leveraging AWS Cloud as well. So we knew that potentially for this solution, we were going to have to create a custom sensor package. Now, by package, we mean device that could be delivered into that difficult environment for sensors. And that would provide us with the core sensor data to process, again, at the edge. And for that, we looked at using the Snowball Edge, which is the big device we have here in front of us today. That was going to give us compute and storage for gathering all of that sensor data. It would also allow us to aggregate through our AWS IoT Greengrass product all of that data, again, at the edge, on the Snowball Edge, for both distribution, detection, and presentation, all locally in the edge environment. And finally, where we did have internet connectivity, we could be able to sync all of the data from the Snowball Edge to our standard AWS cloud environment for further analytics through our services such as Amazon QuickSight. So as a first pass of an architecture, very quickly, and we will dig into this a little bit more, we knew that within the private subnet, where we call the edge environment, with no internet connectivity, we were going to have our sensor packages with private 5G, in this case AWS private 5G, which would provide us with connectivity within the area, and that could be stood up separately even if the local network had gone down. So that was our data conduit. On our Snowball Edge, we would be leveraging our local Amazon EC2 instances for compute, and we could leverage our Amazon S3 standard for storage of all the data coming back in from the sensors over that private 5G. And finally, within the cloud, we could leverage both S3, Amazon Athena for processing, and Amazon QuickSight to build dashboards to provide that insight to operators that were maybe thousands of miles away from where the incidents were happening. So from a sensor package perspective, as an engineering team, we typically concentrate on software, but we did actually build IoT hardware for this. So we built these sensors, quite a number of them, and the idea behind these were these could be deployed into the field quickly, would be connected over 5G, and would gather all of the data that they were seeing back to the Snowball Edge. And we leveraged standard single board computers for this, together with additional what are called hats, or devices that plug in, to provide sensor data like temperature, proximity, microphones, and gas sensors. On top of that, we had the whole suite of what we'd call wireless or RF detection. So wireless interfaces, 4G, 5G for connectivity. We also had a software-defined radio. So the software-defined radio gave us the capability to scan the entire RF frequency in the area that the sensor found itself in to detect those radios or mobile phones. And additionally, we had a camera module on the front that could keep taking constant photos that we were able to do object detection on, and all of that data together with the custom proof of concept code that Envision Engineering wrote, delivered through AWS IoT SDK back to the Snowballs, was used to detect or infer signs of life within that region. From the edge compute perspective, we had to assume that we were connected to the same private 5G in a local environment. And that gave us our S3 for local sensor data. So the raw sensor data from the sensors went straight into S3 on the Snowball. It was then, we leveraged IoT Greengrass data component to aggregate all that data in real time to both feed external clients within the local environment, so we could share that data with other partners that were in the field, maybe to power things like CivTac, if you're familiar with tactical awareness platforms. We could also push that back up to the cloud when connectivity allowed. We could also run other EC2 instances to run things like messaging servers. So our messaging service could connect to other people in the field to push out real-time updates of inferred signs of life, so they knew where potentially to go to help those people. And we also created a local visualization platform that took all the data from the sensors and showed that in real time with a map and the location of each sensor and the object detection for the imagery. So all of that, from the sensors to the Snowball Edge, was all effectively in a disconnected internet state. It was all local processing. Where we did have internet connectivity, either through satellite or maybe public internet, we could leverage that by replicating all of the data from S3 on the Snowball Edge over to our standard AWS cloud environment. Again, leveraging S3 standard on the cloud, and tying that with Amazon Athena for quick processing and the creation of the tables that would then let us derive a real-time dashboard in Amazon QuickSight. And when we say quick real-time, near real-time, the point from gathering a sensor data through the Snowball Edge, through aggregation into QuickSight, was around 15 to 20 seconds. So for operators that were thousands of miles away using the solution, it was as near real time as you were going to get to help them find those signs of life. So in terms of delivery, we spent 2 weeks with the end client in a simulated disaster environment, deploying these sensors all over the place, allowing them to gather all the data and showing how all the data coming back and being shared with other partners within this environment worked. And this was all built on the AWS technology that we've talked about, plus custom proof of concept code that Envision Engineering wrote specifically for this. We also tested the sensor delivery through air and land, and that included drones. We had the absolute joy of watching one of our sensors be delivered by drone and dropped from around 20 feet high, which was awesome. And it did survive. And then on the signs of life, we had the automated messaging that we talked about to other partners. And we drove that through as well into the cloud for further processing. So the sensors themselves were just off-the-shelf standard single-board computers. We used GPIO devices on top for all the sensor data that you saw earlier. and the hardware software-defined radio. And they were also battery-powered. So from a timing perspective, they tended to last somewhere between 6 to 8 hours in the field. So we could deploy up to 10 of them as part of this POC over a geographical area to get those sensors from those different areas. They used the standard single-board computer OS image, but on top of that, we placed AWS IoT SDK, which gave us the conduit back to the edge. And then we paired that with our own custom software to gather all of that data from the sensors. From the edge, from the Snowball Edge perspective, we went with the compute-optimized model. The ML inference that we were doing for this particular project didn't require GPU. We were able to leverage the 52 vCPUs to run as many EC2 instances as we needed for this particular solution, together with the 256 gig of RAM and the 80 terabytes of storage. On top of that, we leveraged the AWS Ops Hub for management of the Snowball Edge in the field, and then leveraged the EC2 with IoT Greengrass and Amazon S3 for the storage and compute. From a software perspective, we built the local web application, which gave us, as well as the sensor location and readings and photography and the visualization and the detection, also ran again directly on the Snowball Edge. So any other partner that was working with us, think NGOs, for example, could connect, if they were on the same network, to that web app live on the edge without requiring internet access. So a true edge environment. And then when we did have the software, internet connectivity, we could replicate that data and analyze it with Athena and QuickSight. So out of everything that we delivered, if we jump back to the remit of EE, we talked about rapid prototyping. So what did this really mean for this customer in this case? 10 weeks. So from the point that we had that first conversation with that customer where they set us that really difficult challenge for detecting signs of life, to those including the final 2 weeks with the customer on site demonstrating what we built, it was 10 weeks. So for EE, rapid does mean rapid. So in terms of what's next for us, from a productionization perspective, we're going to be working with our customer and their partners to productionize the sensor hardware that we built, together with providing them the software that was delivered as part of this POC. We're also going to be iterating on the solution, which is really important to us. So as well as creating what we would call standardized architectures for edge processing within Envision Engineering, we're also looking at how we can improve the software. Obviously, we started with the Snowball Edge. One of the things we did over the last few weeks was take that software and move it onto our Snowcone, which is much more portable. So that conversion of this solution from the Snowball Edge to the Snowcone was done in less than a day, leveraging the AWS technology that we'd already used. And we're also going to be sharing what we've learned. So that means obviously sharing it with customers, but also sharing it with our own teams. So for example, when you registered, you may have seen the big Jeep at the front with our AWS disaster response team. They're doing some amazing work taking that technology into really difficult environments to really help. We're sharing our technology with them to help accelerate their journey and their usage of the sensors as well. So as always, we'll close with, we always encourage our customers and our partners to go and build their skills on AWS. And also to look at the certification. We've had a great time sharing what we've learned with you today. Obviously, we really enjoy teaching our customers how to leverage AWS and drive it forward. Sergey and Fabio have obviously taken you through today how the hardware can be used to really leverage AWS for your business. Yesterday, there was also a session on the AWS local zones, so HYB 202. We really encourage you to go and have a look at that, where AWS local zones can bring AWS services to customers that maybe don't have a region yet, which is really important. So we're going to be downstairs in the main area, back left, I think, today. We'd really love you to come and have a conversation with you, and maybe our next big challenge that we can help you solve is in this room today. Thank you, everyone.